So we've just solved all of these linear systems, and we've used substitution and elimination. We've talked about graphing. You've come up with your favorites for linear systems. Now we need to look at linear inequalities. You'll notice this has kind of been following us as we go through the year. We solved equations and we solved inequalities. Then we graphed equations and we graphed inequalities. And now we're solving linear systems and we're going to graph systems of linear inequalities. What stinks about linear inequalities is the only way to solve them is to graph. There is no other option. So go ahead, try the warm-up on your own, and then we will come back together and we'll start going into systems of linear inequalities. So in the first one, we just want to talk about what the graph would look like. Gotta switch to my marker. We know that it's going to be a dotted line. We know that it's a dotted line because it is less than or equal to. The other thing you should be able to do is plug 0, 0 in. When I plug in 0, 0, I get 0 being less than -1, less than or equal to -1. That is false. So I'm going to shade on the side where 0, 0 is not. Shade where not 0, 0. In the second problem, we are running one ad that costs $6 per day. So we're looking at these two ads, and you have one ad that costs $6 per day. You have a separate ad. It's not the same one, so you cannot use the same variable. So your second ad costs $8 per day. We can spend no more, so this needs to be less than or equal to $120. At this point, this is just going to be guess and check to kind of work your way down through it. You just need one possible combination that could work. I like zeros, so I would actually plug 0 in for x, so 120 divided by 8. So it would be 0 for the first ad, and you could do 15 days for the second. Or I can do vice versa. And I can do 20. We're going to look again at solving systems of linear inequalities. And again, the only way to do it is to graph it. Okay, so we're going to be going back to that basics of graphing. So we have two equations we want to graph. We're going to graph each one separately. And I honestly like different colors, so I'm going to be graphing in different colors. The first equation I'm going to graph in red. So y is greater than -1x plus -2. That gets me a slope of -1 and a y-intercept of 0, -2. And I want you to work with each equation entirely separate. Don't get caught up in the fact that there's two equations. So I have 0, -2. My slope is -1, so down 1, right? 1. It is going to be a dotted line because it is just greater than and not greater than or equal to. When I plug in 0, 0, I get 0 being greater than 0 plus -2. 0 is in fact greater than -2. So I'm going to shade on the side where 0, 0 is. Pretty straightforward and simple. Second equation I'm going to do in green. So y is less than or equal to 3x plus 6. We have a slope of 3 and a y-intercept at 0, 6. So 1, 2, 3, 4, 5, 6. Slope of 3, up 3, right 1. Or down 3, left 1 if you want to do the opposite. This one's going to be a solid line because it is less than or equal to. Again, I'm going to plug 0, 0 in. So 0 needs to be less than or equal to 0 plus 6. 0 is smaller than 6, so I'm going to be shading on the side where 0, 0 is. And I'm actually going to switch colors one more time. At this point, It's just to draw your attention to something. If you look right here, you'll notice that this is an area of the graph that is both colored in green and red. Both lines, the shading overlaps in this section. And that overlapping section is actually the answer. Okay, so the answer is where those two graphs, that shading overlaps. Some people will get very good at these and they'll kind of be able to see where that shading is going to overlap in their head. So they would actually just color in this overlap section. Others of us, me included, I can't see that as well. So I normally use the two different colors, find the overlap. And then I usually take my pencil or my pen or whatever I'm working with and really kind of accentuate the area where that is taking place. Okay, really coloring in, making darker wherever that overlap occurs. And that's it for graphing linear inequalities. That's what we're going to be doing for the rest of the period. So again, same thing. Just going to walk you through one more, starting with the first one. Oh, I want to switch back just to regular red. Regular red. So y is less than 3x. So my slope is going to be 3. My y-intercept is going to be 0, 0. 0, 0, up 3 over 1. So here we're looking at 3 inequalities, so I'm going to use 3 different colors. They all graph the same. You're just going to notice that we're going to look for the overlap of where all 3 meet, just not 2 of them. So the first one, y being greater than or equal to -1, a y equals equation or a y inequality means I'm going to have a horizontal line at -1. It's going to be solid. I'm going to have it in green. If I plug 0, 0 in, 0 is greater than -1. So the green shading occurs on the top of the graph. My second equation is an x equals equation. X greater than -2. That's a vertical line at -2. 0 is greater than -2. So this time I'm going to be, so close to being done. The little stylus point broke again. So I gotta see if I can squeeze it back in there. The stylus does not like having to shade on the graph. Okay, I think that'll work for me. So the blue shading is everything over here on the left. And you'll notice that we're ending up with a box in the upper right-hand corner at this point, where we do have that double overlap. My third and final line, I first need to get into slope-intercept form. In slope-intercept form, it would be y is less than or equal to -1/2 x plus 2. So that's a slope of -1/2 and a y-intercept at 0, 2. So starting at 0, 2, your graph is getting crowded at this point, so it may be hard to see. But down 1 over 2, down 1 over 2. It is going to be a solid line. When I plug 0, 0 in, make sure you plug it into the original equation. I get 0 plus 0 needing to be less than 4. 0 is in fact less than 0 is in fact less than or equal to 4. So the red is going to shade all the way down here. So now it just looks like a big slobby mess. But the area of double shading is actually this little triangle right in the middle of the graph. I guess it'd be triple shading, not double shading. So the only answers that work in all 3 of the equations are in that little black triangle. I want you to go ahead and try this one on your own. It's the same idea, you're just doing all 3 of them. And then turn the video back on when you have a moment. All right, so looking at the first graph, we're going to have a slope of -1. We're going to have a y-intercept at 0, 2. So starting at 0, 2 with my slope of -1, down 1, right 1. It is going to be a solid line. And if I put 0, 0 into my equation, I get 0 being larger than 2. 0 is not larger than 2. So I'm going to shade on the upper part. So I'm going to shade on the upper part of the graph. So now I'm on my second equation. I'm going to switch colors. I'm going to make this one blue. Y is less than 4. So y equals is going to be a horizontal line. So we drew the y line, and actually I forgot it should be dotted, so I'm actually just going to take my eraser. So it's a really nice trick if you ever forget to make your line dotted. You can just take your eraser and go back through. Plugging in for 0, 0, 0 is in fact less than 4. So that's going to be this bottom portion of the graph. And then we have the last line we need to look at is the x less than 3. So x less than 3 is going to give me a vertical line. So it's going to be a vertical line at 3. So we'll switch to green. Vertical line at 3. Again, it will also be dotted. Plugging in 0, 0, 0 is smaller than 3. So that would be this left-hand side of the graph. And again, this time, just like last time, the overlap is that smaller triangle in the middle. It's not always going to be a small triangle in the middle. Sometimes it will be a box in the upper corner. But in these two particular cases, it did happen to be those small triangles. So I want you to go ahead and try these on your own. Go ahead, pause the video if you need to, and then we'll come back and talk about them. So since I don't have the graphs for these, I'm just going to kind of sketch as best I can. So the first graph I'm going to make red. I'm going to start at 0, -4. My slope is up 1 over 1. And it's going to be a dotted line. And when I plug in 0, 0, I end up with 0 being less than -4. That is not true, so I'm going to shade in the bottom half of the graph. The second equation, we'll do that one in blue. So I'm going to start at 3, and my slope is -1 over 1. So you can kind of see where my two lines are going to intersect at. Solid line because it is greater than or equal to. When I plug in 0, 0, I get 0 being greater than 3. That is not true, so I'm going to shade above. My overlap is occurring in the triangle on the right-hand side of the graph. Second problem where we're graphing the 3 lines. Again, I'm going to pick 3 different colors. The first one, we're having a y-intercept of 0, 0 and a slope of -1. Dotted line. I cannot plug in 0, 0 this time, but I can plug in 1, 1. And 1 is larger than -1. So I'm going to color in above the graph or where 1, 1 is located. My second line in blue have a slope of 1 and a y-intercept of -4. So up 1 over 1. So this is going to be a solid line. When I plug in 0, 0, I get 0 being greater than -4. That is true. So I will be shading in over here. Last one, y greater than 5. That will be done in green. That will be a horizontal line at 5. It will be dotted. And 0 is smaller. So I will be shading below, giving me my overlap of a triangle. Larger triangle this time, and an inverted triangle at that. line. Last piece we need to talk about is the graphing calculator. And again, I cannot show you step by step on here with the graphing calculator, but basically you're going to go to that y equals screen. Remember that you put your cursor on the equal sign and hit alpha and then whatever inequality symbol you want at the bottom of the screen. That's the easiest way to get it to the inequalities. Plug in each of your equations, make sure they're in slope-intercept form, and hit graph. If you remember when we graphed inequalities before with the graphing calculator, it does in fact take a little longer. When you're graphing 2 or 3 inequalities, it takes even longer. So please make sure that you are giving the calculator the appropriate amount of time. Homework tonight, worksheet like traditional. If you have questions on anything, please let me know. If you do not have your worksheet in front of you, it can always be found online.